Hey everybody, and welcome to a video working through some probability example problems. In the last video, we used the probability axioms to derive some basic probability rules that we can use in computing probabilities. In this video, we're going to put those rules to use. Now, I first want to highlight that in this course, there's going to be a number of different types of example problems that we'll use on homeworks, on exams, in these videos. Some of them are going to be very practical problems, medical problems, legal problems, so on. But a lot of them are going to be sort of artificial gambling problems, right? So we'll see a lot of examples that involve coins, flipping coins multiple times. A lot of examples that involve urns, right? An urn is like a vase with balls in it. We'll talk about the probabilities of pulling different balls from urns. And also a lot of problems that involve cards. Right? So what I want to first do in this video is talk about a standard deck of cards and make sure we're all on the same page in what a standard deck of cards consists in, because a lot of the examples and problems we'll use in dealing with probability will involve a standard deck of cards. Now, a standard deck of cards has 52 cards total in it. And these cards, these 52 cards, are divided up into 4 suits. Okay? And the suits are the spades, which kind of look like they're a black card that kind of looks like that. Clubs, which kind of look almost like a clover or something. They're also a black card. Then there's hearts, which look, as you may have guessed, like a heart, and they're a red card. And then there are the diamonds. And the diamonds are also a red card, and they look like, you guessed it, a diamond. So these are the 4 different suits. So each of these suits has the same number of cards in it. So if there's 52 cards total, and there's 4 suits and they each have the same number, that means there has to be 13 cards in each suit. So there's 13 spades, 13 clubs, 13 hearts, 13 diamonds. And those 13 cards are sorted by rank. Okay? And the rank for each suit starts with ace, which is kind of like 1, and it goes then starts going through numbers 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So all the numbers 2 through 10 are in there, and then afterwards you have what are called the 3 face cards, right? And those are a jack, a queen, and a king. Okay? Altogether, this makes 13 cards. So there's 13 of these cards for the spades, right? So there's ace of spades, 2 of spades, and so on. There's 13 of these cards for the clubs, right? So there's ace of clubs, 2 of clubs, and so on. Similarly for hearts and diamonds, right? And that gives us our 52 cards total. So you want to have if you're not familiar with the standard deck of cards or playing cards, I would get a good familiarity with the deck of cards, with what the suits are, and the ranks, so that you're able to answer the questions on the exams and homeworks with some familiarity of a deck of cards. All right, now what we're going to do is we're going to answer some questions about probability that involve a deck of cards using the rules that we derived from the probability axioms in the last video. Okay, so I'm going to take these questions from the Skirms textbook. They're an exercise on page 117. You want to look at the textbook. So the first question, right, we're going to draw one card from our deck of 52 cards. And we're going to assume that every card in the deck has an equal probability of being drawn, right? That means each card has a probability of 1 out of 52 of being drawn. So we're assuming each card has probability 1 over 52 of being drawn. Okay? Now the first question is, what's the probability that we will draw the ace of spades? Well, this is really easy, right? Because the ace of spades is just one of those 52 cards, and each card has a probability 1 out of 52 of being drawn. So here, clearly, the probability is 1 out of 52, right? That's sort of a gimme. Then we ask, what's the probability of the queen of hearts? Well, again, the queen of hearts is just another one of those 52 cards, so it too has a probability of 1 out of 52 of being drawn. Easy, right? We'll do one. Here's a fault. Doing a little bit more. We want to know the probability that we'll draw an ace of spades or a queen of hearts. So we really want here the probability of a disjunction, right? Well, maybe I'll use A to represent the proposition that we draw an ace of spades, and I'll use Q to represent the proposition that we draw the queen of hearts. Then what we're really interested in is the probability of the disjunction A or Q. Right? Now, we can use general disjunction rule to find out what this probability is, or if the two propositions are mutually exclusive, we could use the additivity axiom. Now, in this case, right, drawing an ace of spades and a queen of hearts are close enough to being mutually exclusive, right? So, in a sense, they're not really logically mutually exclusive, right? If we draw a truth table, we wouldn't get the conclusion that they were logically mutually exclusive. But we're sort of assuming that they're mutually exclusive here because we're assuming that we're only going to be able to draw one card from the deck, right? And that a card can't be both an ace of spades and a queen of hearts, right? But if we want to be safe, we can use the general disjunction rule, since these are not, logically mutually exclusive. And it's always fine to use the general disjunction rule. And we'll get that this is equal to probability of A plus probability of Q minus the probability of A and Q. And here's really the kicker, right, is that we're really making this assumption that the probability of A and Q is 0, right? So what we have is we know the probability of A is 1 out of 52. That's what we just said. And the probability of Q is also 1 out of 52. That's what we just said. And the probability of both of them happening is 0. So we get the probability of drawing either the ace of spades or the queen of hearts is 2 out of 52, right? Or 1 out of 26. All right? So that's a simple use of general disjunction rule. Now, let's ask, what's the probability that we draw an ace? Okay? Now, an ace, right? How many ways could we draw an ace? Well, we could draw the ace of spades, we could draw the ace of clubs, we could draw the ace of hearts, or we could draw the ace of diamonds, right? So there's really 4 possibilities here. So we could really view this as a disjunction, right? I'm going to use, let's say, A1 to represent, well, actually, maybe it'd be more convenient. I'll just use A sub S to represent drawing the ace of spades. A sub C represents drawing the ace of clubs. A sub H represents drawing the ace of hearts. And A sub D represents drawing the ace of diamonds. And what we really want to know is the probability of the disjunction of all of these, that I either draw an ace of spades, or an ace of clubs, or an ace of hearts, or an ace of diamonds. Now, these are all effectively mutually exclusive with each other, right? Because the probability of drawing, right, of getting a card that's both, say, the ace of spades and the ace of clubs is 0, right? Can't happen. Similarly with each of these pairs. If we wanted to, we could work through this really carefully, since these are not strictly logically mutually exclusive. And we could take this sort of in turns and realize that, okay, this is really a disjunction between ace getting an ace of spades and this big disjunction that says we get one of the other aces. And so we can apply general disjunction rule to that and get this is equal to the probability of drawing the ace of spades plus the probability of getting ace of clubs, or ace of hearts, or ace of diamonds, right? Minus off the probability that we would get both, right? Ace of spades and, right, one of these others, right? Ace of clubs or ace of hearts. or ace of diamonds. And we know that this probably is just going to be 0 here, right? Because you can't get both the ace of spades and one of those other ones if we're just drawing one card, right? So, right, I'm going to say this is 0 here, right? That's 0. So this probability of getting the ace of spades plus the probability of getting ace of clubs or ace of hearts or ace of diamonds. So, right, the 0 just falls off. Now I can look at this case right here, right? And here I have the probability, I can view this as looking at the probability of a disjunction between getting an ace of clubs and getting either an ace of hearts or an ace of diamonds, right? So this then becomes probability of ace of spades plus, through another application of general disjunction rule, in the probability of ace of clubs plus probability of ace of hearts or ace of diamonds minus, right, the probability that I would get both ace of clubs and ace of hearts or ace of diamonds, which again is going to be 0. Right? So we have then probability of ace of spades plus probability of ace of clubs plus probability of ace of hearts or ace of diamonds minus 0. Right? Again, that falls out. So you can see where this is headed. We're just going to end up with the sum of all of these. Probability of ace of spades plus probability of ace of clubs plus probability of ace of hearts plus probability of ace of diamonds. Of course, minus the probability we get both of those, but that's just 0. So this then, we know the probability of getting each one of these individual cards is 1 out of 52. So we're just adding 1 over 52 plus 1 over 52 plus 1 over 52 plus 1 over 52. Right? So we get 4 out of 52 or 1 out of 13. Right? So that's the probability that we get an ace. Right? Not too bad, right? You could probably have done this much more quickly than we did here, but I wanted to show the explicit working of this out in terms of general disjunction rule. All right, the next question we want to ask is, what's the probability that we get a heart? Right? And here I won't work through it quite as explicitly, but we realize that there's really 13 possibilities here for getting a heart, right? You could get, maybe I'll write it like this. You could get a heart that's an ace. You could get a heart that's a 2. You could get a heart that's at 3, and so on, all the way up to a heart that's a 10, and then, of course, the face cards, right? A jack, a queen, right, and a king. So there's 13 possibilities for what you could get. Now, so what we really are asking for is the probability of a big disjunction, right? Probability that one of these is true. You get either the ace of hearts or the 2 of hearts, or right all the way up to the king of hearts. Right? Now, right, again, all of these are in a sense, right, even though they're not logically mutually exclusive, right, the probability of any 2 of them being true, we're sort of positing is 0. So that enables us to just sum up, right, with multiple applications of additivity. So we can just really view this as the sum of the probability of getting the ace of hearts plus, right, 2 of hearts, right, and so on up to the king of hearts. Right? And we know each one of those probabilities is 1 out of 52. So what we're really doing is we're adding up 1 out of 52 13 times. Right? And that leads to 13 out of 52, or in other words, right, 1/4. Right? Which is what you might have guessed, right? We said, right, 1/4 of the cards are hearts. So, of course, the probability of drawing a heart is going to be 1 out of 4. All right, but that shows you sort of how we can think of this in terms of the disjunction rule. Now, the next question we're going to ask is, what's the probability of getting a face card? Now, face cards are jacks, queens, and kings, right? So really want to know the probability that we get a jack, king, or queen, right? So we really want, I'll use J to represent the proposition we get a jack, Q represents that we get a queen, and K represents that we get a king. We're again asking for a disjunction, right? The probability that we would get J, or Q or K, right? Now, right, again, right, the probability of getting any two of these, right, getting both a jack and a queen, or both a queen and a king, right, is going to be 0, right? So we can treat these effectively like they're mutually exclusive, right? So then we're just summing up the probability of getting a jack plus the probability of getting a queen plus the probability of getting a king. Now the probability of getting any particular rank is the same, right? And we already computed the probability of getting an ace, right? We said that was 4 out of 52. So each of these are going to be the same by the same sort of reasoning, right? So it's 4 out of 52 plus 4 out of 52 plus 4 out of 52, which gives us 12 out of 52. That's the probability of getting a face card. And we're just randomly drawing a card from the deck. All right, next question. A card that is not a face card, right? A card that is not a face card. Now we can employ negation rule, right? Because if I let, right, let's say that F is the proposition that we get a face card, right? So I wrote that before as J or Q or K, right? What I really want now is the probability of not F, that we don't have a face card, right? But by negation rule, that's just 1 minus the probability of F, which we already found in the last problem was 12 out of 52. So we want 1 minus 12 out of 52, right? Which is going to be 40 out of 52. That's the probability of getting a non-face card. So that's a nice, easy application of negation rule. Next question we want is the probability of getting an ace or a spade. Okay? So again, we could use maybe A to represent the proposition we draw an ace, and S to represent the proposition that we draw a spade. Then what we're interested in is the probability of this disjunction A or S. Right? Now we can use general disjunction rule, as we always can, right? It'll be the probability that we draw an ace plus the probability that we draw a spade minus the probability that we draw both an ace and a spade, right? That's really just the probability that we draw the ace of spades, right? Now we already know, right, the probability of drawing an ace, right? That is 4 out of 52. The probability of drawing a spade is the same as the probability of drawing a heart, right? Because each of the suits have the same probability of being drawn. So we already computed it for the probability of drawing a heart. So by the same reasoning, we're going to get the probability of drawing a spade is 1/4, or we could write as 13 out of 52. And then minus off the probability of getting an ace and a spade. Remember, that's just the probability of drawing that one card, the ace of spades, which is 1 out of 52. Right. So we get 4 plus 13 is 17, minus 1 is 16, so we get 16 out of 52 is the probability of drawing either an ace or a spade. So this was the first one that was a little more subtle, right, because the events drawing an ace and drawing a spade were not mutually exclusive, right? They could both be true, right? They could both happen. So this was a case where it was really necessary for us to use general disjunction rule. Now, next question we could ask is the probability of drawing a queen or a heart. Now let's use Q to represent the statement that we draw a queen, H to represent the statement that we draw a heart. Then what we really want is the probability of Q or H. Okay. Now by general disjunction rule, this is the probability of Q plus the probability of H minus the probability of both happening, Q and H. Okay? Now, we know the probability of getting a queen is just going to be the same as the probability of drawing a card of any particular rank, which we had said was 4 out of 52, plus the probability of getting a heart. We already computed that as 1 out of 4, or 13 out of 52, minus off the probability of getting a queen of hearts, which is 1 out of 52, right? The probability of getting that particular card. So again, this is the same as before. In the last problem, it's 16 out of 52. All right. Next question. What about the probability of drawing a queen or a non-spade? A queen or a non-spade. So here, right, let's use Q to represent the statement that we draw a queen. And we'll use S to represent the statement that we draw a spade. So what we really want then is the probability of Q or not S, that we don't get a spade. So again, this is a disjunction, so we can use the general disjunction rule. It's equal to the probability of Q plus the probability of not S minus the probability of Q and not S. Okay? So we know the probability of Q is 4 out of 52, probability of drawing a queen. The probability of drawing a non-spade, well, we can use negation rule there, right? It's going to be 1 minus the probability of drawing a spade, right? And minus the probability of Q and not S. So we know the probability of drawing a spade, right? That's 1 out of 4, 13 out of 52. So we can fill that in, right? We get 4 out of 52 plus 1 minus, right, 13 out of 52 minus the probability of Q and not S. So this then gives us, right, 1 minus 13 out of 52 is going to be 39 out of 52. So we get 4 out of 52 plus 39 out of 52 minus probability of Q and not S. So now we just have to figure out what probability of Q and not S is. Right? So this is the probability of getting a queen, and it's not a spade, right? So what are the possibilities there? Well, we could get the queen of hearts, right? Queen of hearts, or we could get the queen of clubs, or we could get the queen of diamonds, right? Those are the three possibilities if we get a queen that's not a spade, right? So we could really view this as 4 out of 52 plus 39 out of 52 minus the probability of that disjunction, right? Getting a queen of hearts or queen of clubs or queen of diamonds, right? But we know, right, that each one of those has a probability of 1 out of 52 of happening. And we know that since the probability of any two of them happening together is 0, we can just add those up, and we'll get 4 out of 52 plus 39 out of 52 minus 1 out of 52 plus 1 out of 52 plus 1 out of 52. So we're basically doing minus 3 out of 52, right? So that's going to wind up being, let's see, 4 out of 52 plus 39 out of 52 gives us 43 out of 52. Minus 3 out of 52 is just going to get us back to 40 out of 52. All right? So hopefully some of these examples are helpful. We're going to have lots of examples like this on homeworks and exams. So you really want to get familiar with using these rules, particularly general disjunction rule and negation rule, and the logical equivalence rule to compute probabilities. Also familiarize yourself with the deck of cards if you're not familiar with it yet. Please answer the participation poll for this video, and I'll see you next time. Thanks, guys.